Are you struggling to bring your game ideas to life in Unity? You might think scripting is too complicated or time-consuming, but what if I told you it doesn't have to be that way? In this video I'm going to show you how learning the basics of C# scripting in Unity can simplify your game development process and make it more efficient. We'll introduce you to scripting in Unity using C#. By the end of this tutorial you'll understand the basics of C# programming and how to write your first script to control game objects in Unity. Stick around for a special debugging tip that will make your development process smoother. Before we dive in, make sure to subscribe and hit the bell icon to stay updated with our latest game development tips and tricks. In Unity, scripts are written in C# and are used to make things happen in your game. To create a new script, we have two options. We can come here to Assets, Create, Scripting, and we can select Mono Behavior Script, or we can right click here in the project window, Create, Scripting, Mono Behavior Script. Let's name it something like Player Controller and let's open it. You'll see a basic template that Unity provides, which includes using statements, a class definition, and two methods, start and update. Let's start with some basic programming concepts. This will help you understand scripting in Unity. We'll cover what a variable is, what it's used for, what a function is, and what a class is. A variable is like a container that holds information. Imagine you have a box labeled speed and you put a number in it, like 10. You can use this number later in your code. Here's how you declare a variable in C#. Let's add some empty spaces here, and then let's write public float and let's call it speed. And that's how you declare a variable of type float. First we have the access level. In this case is gonna be a public variable, we'll talk about this later. Then we have the type of our variable, in this case is gonna be a number with some decimals, and then the name of the variable. A function is basically like a set of instructions that tells the computer what to do. It's basically like a recipe that you follow to bake a cake. In Unity, start and update are functions. You can also write your custom functions to do whatever you want. For example, move a player. Here's a simple function, void and then move player, and then we can say here code to move player. This is a comment which will not do anything, but it will let us know what that code should do. A class is like a blueprint for creating objects. Think of it as a design for building a toy car. In Unity, scripts are classes that tell the game what to do. What we have here is basically a class in C#. It is declared as public class and the name of the class. We'll talk later in this course about this. Let's talk a bit about the script structure. The start method runs once when your game starts. This is a very good place to set up your things. For example, to give your variables a value, the update function will be called. So basically everything that we put in the update function will be called every single frame. So basically here you put the code that you need to happen continuously, like moving a character. If you have questions or topics that you'd like me to cover next, leave me a comment below. I love hearing from you. And don't forget to stay tuned until the end for a special debugging tip that will help you keep your code clean and efficient. Now let's start writing and attaching our script. We already declared a public variable called speed, and in the update function we'll need to read the input from our keyboard, and let's do that right now. I will say float and let's call it move horizontal equals to input.getAxis parentheses, and then I will write horizontal and semicolon. I will do the same thing for the vertical axis. I will say float move vertical equals to input.getAxis, and I will say vertical, and Unity knows that the horizontal axis means the left and right arrow keys or the A and D keys. The vertical axis are actually up and down arrows or the W and S keys. Now, since we are working in a 3D space and we only have two axes, we will need to write a vector3 variable. So for that I will say vector3 and let's call it movement equals to new vector3, and here I need to set the value for the three axes, X, Y, and Z. Now for the X axis, which means basically the horizontal one, I will use move horizontal variable. For the y-axis, which is basically up and down, I will say, usually you would think that I will use the vertical axis, the move vertical, but in this case I want my object to move on this plane, and actually let's create a new cube here, and then let's reset its value to 0, 0, 0, and let's bring it up just 0.5. So you can see here the x-axis is the red one, the y-axis is the green one, and the z-axis is the blue one. So the horizontal axis here is the red one, is the x-axis, and it's moving from left to right. Now in this case I want this cube to move on the surface of my plane, so I want it to move on the x-axis and the z-axis. So the y-axis is gonna remain unchanged, so for that I will go back here and I will say 0.5 because the cube is right now at 0.5. I want to keep that value. I will say 0.5 f because it's a float. It needs that f character after the value, and then for the z-axis I said that I want move vertical. Perfect. But this is not enough. I just created a new vector3 variable and I need to use it to move my character, or my cube in this case. So for that, because I will use this script on my cube, I will say transform.translate and I will give it the variable movement that I declared before of type vector3. And now I actually need to say how fast it should move. Making the movement independent of the frame rate is crucial to ensure consistent gameplay across different devices. If movement is tied directly to the frame rate, players with higher frame rates would experience faster movements, while those with lower frame rates would find the movement sluggish. By multiplying movement calculations by time.delta time, which represents the time elapsed since the last frame, you normalize the movement speed, ensuring that all players have the same experience regardless of their hardware capabilities. So I will multiply this by speed, and if you remember, I said before that I want this to move at the exact same speed independent of the frames per second. So I will multiply this by time.delta time. Now let's try this. I will save it first. Let's save their controller, and now with my cube selected I will come down here in the inspector, add component, and write player controller, and this is gonna be the script that I written right now. I will select it, and here we can see the variable speed that is set to 0, and I want it to move, let's say, with 10 units per second. Let's save, and then let's click play. Now I do have a bug here. When I press play, my cube will go up and up, and that is because in the script, instead of 0.5f, it should have 0f, because this way I don't want to add any value, any movement on the y-axis. So it will keep the value constant on the y-axis. Now if I will try again, press play. If I will press, let's say, the D key, my cube will go to the right, and then if I'll press the A key, my cube will go to the left. The same thing goes for the W and S keys, and also the arrows. Now the speed is way too high, so I'll set it back to 5, and then my cube will move slower. Here's a game changer: debugging your scripts. Use debug.log to print messages to the console. This is incredibly useful for checking variables' values and understanding the flow of your script. For example, you can add debug.log statements inside the update method to see the values of the input axis or the player's position. If we want to see the values for the move horizontal and move vertical, we can use a debug.log, and here we can say horizontal and then plus and then move horizontal, and we can do the exact same thing for vertical, debug.log, and let's say vertical plus move vertical. I will save again. If I don't save, or if I don't go here and save from this menu, I usually use Ctrl+S just because I got used to it and it's way easier for me that way. Now in the inspector I will select the value for speed again to 2, and then I will look in the console. We can see the horizontal and the vertical values are 0, and you can see the number of times these messages are incrementing, and if I'll press D, you can see the value of the vertical axis actually increased again, and is somewhere up here, it goes up to a value of 1. Now if I will press the S key, in this case, let's see what happens. The value becomes negative. So basically, depending on the button that I press, in this case pressing S means that the cube should go backwards instead of forwards, the value of the vertical axis becomes negative. The same thing will happen if I will press A. If you noticed before, when I will press A, the value for the horizontal, it goes below 0, it goes to -1. If I will press D again, it will go up to 1. So basically, the axis will have values between -1 and 1, where 0 means there is no input whatsoever. So there you have it. This is how you write a basic movement script. Now for the special debugging tip, conditional debugging. Instead of having debug log statements cluttering your code, use conditional compilation to print debug messages only when needed. By defining a debug symbol, you can ensure that certain logs are only active in debug mode and not in the final build of your game. Here's how you do it. In your script, let's move these two debugs, right click and then cut, and then let's move them right here, paste, and then let's wrap them with an if, and I'll say hashtag if debug, and then after that I will say and if. Now to define a debug symbol, you can go to edit, project settings, player, I'll have to come down here to other settings, and down here to scripting define symbols, we can press this plus button and let's name it debug. I'll press apply, and that's it. Now, if I will go back in Unity and I'll press play, I will still have these messages in my console. But if I will make a build of my game, that code will be ignored and it will not appear in my final game. By doing this, you keep your production code clean and ensure that debug messages are only active when you need them during the development. It's a powerful way to keep your code base professional and maintainable. Scripting in Unity with C# is a powerful way to bring your game to life. By understanding the basics of C# programming, creating and attaching scripts, and using debugging tools like conditional debugging, you can control every aspect of your game. This not only enhances your game, but also makes development more efficient and enjoyable. If you found this video helpful, give it a thumbs up and subscribe to Geek-Tec Studio for more Unity tutorials. Don't forget to hit the bell icon so you never miss an update. Leave a comment below with any questions or topics you'd like me to cover next. Happy developing, and I'll see you in the next video.